back. In the previous episode, we have learned incidence rate. In this episode, we are going to introduce another important commonly used measure for disease occurrence. Prevalence rate, which refers to the number of existing cases of a disease or health condition in a population at some designated time. This graph shows how to define prevalent cases in a population. Those who already had the disease at the baseline called it prevalent cases. Prevalence rate measures all the disease in a population in a given time point or period, both new and ongoing, and is used to describe the burden of a disease. So it is helpful for policymakers to plan level of health services required in a population. Prevalence rate may be calculated at a point in time, we call it point prevalence, or over a given period of time, we call it period prevalence. Point prevalence is the proportion of a population that has the disease of interest at a particular time. Usually, the denominator is the number of persons screened by a diagnostic method, and the numerator is the number of ill persons found among the screened population. The period prevalence is the proportion of a population that has the disease of interest during a specified period of time. The period could be a week, month, or longer time interval. In the calculation of period prevalence, for the numerator, combine the number of cases at the beginning of the time interval with the new cases that occur during the interval. Cases are counted even if they die, migrate, or recur during the period. The left figure shows 5 cases of a disease in a community in 2012. The first case of the disease occurred in 2011, and the patient died in 2012. The second case developed in 2012 and continued into 2013. The third case was a person who became ill in 2012 and was cured in 2012. The fourth case occurred in 2011, and the patient was cured in 2012. The fifth case occurred in 2011 and continued through 2012 and into 2013. What about the numerator for point prevalence in 2012? This depends on when we do our prevalence survey. If we do the survey in March, the numerator will be 5. If we do the survey in July, the numerator will be 3. And if we do it in December, the numerator will be 2. Thus, the prevalence will depend on the point during the year at which the survey is performed. In this example, what is the numerator for instance in 2012? We know that incidence counts only new cases, and because 2 of the 5 cases developed in 2012, the numerator for instance in 2012 is 2. What's the relation of 2 types of prevalence, as well as cumulative incidence? Let's take a look at the table using questions regarding asthma. If we want to know if you currently have asthma, we use point prevalence. If we want to know have you had asthma during the last year or last N years, we use period prevalence. If we want to know have you ever had asthma, we use cumulative instance. Figure in this slide shows the relationship between incidence and the prevalence. The flask represents a community, and the bees in the flask represent the prevalent cases of the disease in the community. How can we add to or increase the prevalence, as seen in Figure B? We can do so through instance by the addition of new cases. What if we could drink bees from the flask and lower the prevalence? How might this be accomplished? As seen in Figure C, it would occur through either death or cure. Clearly, these two outcomes represent a major differences to a patient, but with regard to prevalence, cure and death have the same effect. They reduce the number of diseased persons in the population, and thus lower prevalence. Therefore, what exists in the dynamic situation shown in Figure D? A continual addition of new cases. Instance, increase the prevalence, while death and or cure decrease the prevalence. We have discussed about the relation between prevalence and rate. In these slides, we have taken one more example to explain the difference between proportion and rate. The figure shows breast cancer incidence rates in white women and the distribution of cases by age. The pattern of incidence rate is continually increasing incidence with age, while the patterns showed in the histogram, the distribution of breast cancer cases by age is not the same. It is increased and then decreased with age. So, if the incidence is increasing so dramatically with age, why of all the patients, there are only fewer than 5% of the cases occurring in the oldest age group? The answer is that there are very few women alive in that age group, so that even though they have a very high risk of breast cancer, the group is so small that they contribute only a small proportion of the total number of breast cancer cases seen at all ages. For example, when insulin first became available, what happened to the prevalence of diabetes? The prevalence increased because diabetes was not cured, but was only controlled. Many patients with diabetes who formerly would have died now survived. Therefore, the prevalence increased. However, there are several problems with incidence and prevalence measurements which needed to be notified. The first problem is defining who has the disease. Let's take an example. A cohort of 1,879 men and women at 65 years old and older who were enrolled in the Canadian study of health and aging were examined. The proportion who were given a diagnosis of dementia using 6 commonly used classification systems was calculated. Depending on which diagnostic system was used, the proportion of subjects with dementia varied from 31% to 29.1 percentage. I'm sorry, from 3.1 percentage to 29.1 percentage. The second issue relating to numerators is that which persons should be included in the numerator? How do we find the cases? We can use regularly available data or conduct a study specifically designed to gather data for for estimating incidence or prevalence. In many such studies, the data are obtained from interviews. Ideally, we would have laboratory or other confirmatory evidence. However, often such evidence is not available. Some of the potential limitations with interview data are listed in the table below, including problems caused by difficulties in diagnosis or problems associated with the study participant. For example, the participant may be reluctant to provide accurate information or too ill to respond, or problems associated with the interviewer. Interviewer may ask question incorrectly or record it incorrectly. The other problem is with the denominators because selective undercounting of certain groups in the population may occur. For example, hysterectomy is one of the most commonly performed surgical procedures in the United States. This raises a question about uterine case rates. For if we include women who have had hysterectomies in the denominator, clearly they are not at risk for developing uterine cancer. The figure shows uterine cancer incidence rate from California. Both uncorrected rates and the rates corrected for hysterectomy are presented. We see that the corrected rates are high. Why? Because in the corrected rate, women who have had hysterectomies are removed from the denominator. Consequently, the denominator gets smaller and the rate increases. However, in this case, this change over time is not significantly changed whether we use corrected or uncorrected rates. And the last problem is with hospital data. Data from hospital records are one of the most important sources of information in epidemiologic studies. However, the table lists some of the problems that arise in using hospital data for research purposes. Hospital admissions are selective in relation to admission policies. Severity of disease. Hospital records are not designed for research, so is incomplete or missing. That is all. Thank you, everyone.